Assalamualaikum and a very good day to you all. In this video, I would like to share with you on how to determine the determinant of a matrix by using the properties of determinant. So we can get the determinant of A by manipulating four important properties of determinant. This way, no expansion along any row or any column required. So this is the first one, whereby we have K multiplied by the matrix, and we can factor out the constant and take the power of the dimension of the matrix. The second one is the multiplication, the determinant of a product matrix A and B equals to the multiplication of the determinant of each matrices separately. The third properties is the determinant of a transpose is equal to the determinant of the matrix. And last but not least, the value of the determinant changes sign when two rows or two columns are interchanged. Let's start with two matrices A and B, and we have been provided the value of determinant A, which is 2, and determinant of B, which is 5. Now, how about the determinant of this new matrix? As you can see from here, there are peculiar number in front of each element, which is 3. So, we can factor the number out of the determinant. So, we can apply the first property. So, as we can see over here, we can factor out the 3 out of the matrix. So when the 3 is out here, we get A, B, C, D, which is a matrix A. Then we substitute the value of the matrix. And then when we take out the constant 3 outside the sign of determinant, we have to take the power of the dimension of the matrix. So as you can see over here, the matrix A is 2 by 2 matrix. Therefore, the n or the power of the constant is 2. Then we calculate 3 squared is 9 and substitute the value of determinant A by 2. There we go, 18 as the final answer. So how about this 3 by 3 matrix? If we have been given the matrix, the determinant equals to 4. Let's find out in the next slide. So, we can see over here there are 2 in each element of the entry, of the element in the matrix. We can factor it out like this. And then this whole thing is the matrix. Okay, over here we can see that we are trying to factor out the 2 out of the determinant symbol. Now, you can see over here it's 2 power 3. Why the power is 3? Because the matrix that we have, we factor, is a 3 by 3 matrix. So the n or the dimension is 3. Therefore, we have to take the power of 2 to the power of 3 to get 8, and we substitute the power of, we substitute the value of 4, the matrix A, B, C, D, E, F, G, H, I. Then we multiply them to get 32. Let's continue with the next one. How about the determinant of the multiplication of A and B? From the second property, we have been told that the determinant of A and B equals to determinant A multiplied by determinant of B. So by using this property, we can simply separate them like this and then just substitute the value of determinant A by 2 over here and substitute the value of determinant B by 5 to get 10 as the final answer. Let's continue with the third property. The third property states that the determinant of a transpose is equal to its own matrix. So, it's like we just take out the T and then make it gone. That's all. Okay, because they have the same the same amount of determinant. So given that A is 2, the determinant of A is 2, okay, so the determinant of A transpose is equals to determinant of A. So we can substitute the value by 2, therefore we get the value of 2. Easy peasy. Let's conclude with the last property. The last property states that the value of determinant changes sign when two rows or two columns are interchanged. So, as you can see here, this matrix has BD as the first column and AC as the second column. But if we are going to switch them up, switch the rows, the second row to become the first row and the first row become the second row, we have to put a negative sign outside the determinant. So how about the determinant of this 3 by 3 matrix? If we have been given this one, this determinant is 4. So let's find out. So the given determinant is GHIDEF ABC. If we compare to the provided ones, we have ABC in the first row. So this one, we have them in the third row. And also, we have GHI in the third row. But in the given matrix over here, we have it as the first row. So, third row has moved to the first row. And first row has moved to the third row. So, we can switch them back and put negative in front of the determinant. Now we can substitute the value of determinant A, B, C, D, D, E, F, G, H, I by 4, the one that has been provided from the question. Then we multiply it by negative, therefore we get minus 4 as the answer. Let's consider the first example. Use the properties of determinant to find the value of x. Given that this determinant equals to the one on the right. Okay, now let's compare them. Yeah, let's compare them. As you can see over here, 1 to 1 in the first column, it equals, but on the right hand side determinant, we have 1 to 1 as the first row. So it's like we are having transpose over here. Yeah. So we can take the transpose back without changing any value of the determinant, without put any negative sign in front of the determinant. So we can transpose it. We just transpose the right hand side determinant to become this one. Then we can compare them according to the entries. So from here, x equals to 2. Let's consider the second example. Given that the determinant of this 3 by 3 matrix is 9, find the first matrix over here. So if we compare, if we look at carefully, yeah, minus 2, 1, 3. Minus 2, 1, 3. So, maybe, okay. Now, the original matrix, we have minus 2, 4, 5 as the second column. Yeah? But it has moved to the first column. So, first column and second column are switched. Okay? So, we can switch them back. Okay, we can switch them back, but we have to put negative outside the determinant. Then, we can substitute the whole determinant here by the value provided from the question, which is 9, and then we have minus 9 as the answer. Let's continue with the second one. Now, we have 6 minus 4 and 2. This is a little bit different, way different than what we have over here. Now we can see the different number is because we multiply all elements in the determinant has been multiplied by a factor of 2. Okay, so we can factor out 2 from each element and take out the 2 and put it outside of the determinant symbol. But after we put 2 outside, we have to take the power of 3. Why 3? Because the dimension of the matrix, or the dimension of the matrix is 3. Okay, it's 3 by 3 matrix, then the dimension is 3. So that's why we are taking 2 to the power of 3, which is 8. And then, oh yes, we have to move the first column and the third column. We have to switch them because the original one has been provided 1 to 1 as the first column. But we have here 3 minus 1 minus 2 as the first column. So we have to switch them back, and don't forget to put negative outside. When we get here, then we can substitute the value of determinant by 9. Then we got minus 72. Okay, let's consider example 2C. Okay, how about this one? Okay, maybe everything is multiplied by 3. Minus 3 to be exact. Yeah? So we factor out minus 3 from each element. Okay, and then we take minus 3 to the power of 3. For this one, you have to be careful. When you use your calculator, you have to put bracket minus 3 inside the bracket. Then you take the power of 3. Okay? If you didn't, then you get wrong answer. Okay, can we substitute the value of determinant at the back here? Cannot, because the first column here, you see 1, 1, 2, right? 1, 1, 2. But the first column provided in the question is 1 to 1. So what happened? What happened was the second row and the third row will switch. So we have to switch them back and put negative outside the determinant. Then we can substitute it by 9 to get minus 243 as the final answer. Let's consider example 3. Given that a determinant of A is 3 and determinant of B is minus 5, find the value of determinant AB. So this one, we have to use the previous properties that we have learned. Yeah. So the multiplication, we can separate them easily like this. Yeah. And then we just substitute the determinant of A and B separately and multiply them to get minus 15. So for the second one, B squared equals to B multiplied by B. This one also share the same properties as the previous one. So we just separate them like this, and then we substitute minus 5 individually to get 25. Okay, let's go to the third one, BA to the power of 3. Okay, over here you can see BA to the power of 3 is BA multiplied by A multiplied by A. So we can separate them. Determinant B multiply determinant A multiply determinant A multiply determinant A. So all these determinants, we can replace them by their respective values to get minus 135. Okay, for the last one is the multiplication of A transpose and B transpose. First thing first, we can separate them like this. Determinant of A transpose multiplied by determinant of B transpose. Next, we can get rid of the transpose symbol because they share the same determinant. So it just becomes determinant of A and determinant of B. Then we can substitute it by its respective value to get minus 15. I think that's all. Thank you for your time and attention. Assalamualaikum and a very good day.